Now we just want to look at some problems that involve combinations of fractions, mixed numbers, add, subtract, multiply, and divide, and maybe even some exponents. Here's our first one. Let's just simplify. 3/5 plus 1/10 times 1/2 plus 3/4. So let's see. I'm going to work inside the parentheses, get a least common denominator of 10. So 3/5 I'm going to write as 6/10 plus 1/10. Because I need to multiply 5 by 2 to get 10, so I multiply 3 by 2 also. And then here the least common denominator is 4, so I'll multiply top and bottom of this fraction by 2, so I'll end up with 2/4 plus 3/4. Now that looks pretty simple. 6 and 1 is 7/10 times 2 plus 3 is 5/4. I have a common factor of 5 that I'll divide out here. In the numerator I have left 7, in the denominator I have left 8. So 7/8 is the result of simplifying this expression right here. Just a problem involving adding fractions and then multiplying fractions. Here's another one. Let's see, I need to add inside these parentheses first, and then I'll take care of that exponent. So this is going to be 2 3/8 plus 1/2 times 1/3 plus 5/3 is going to be 6/3. And that's going to be cubed. Now 6/3 I notice is 2, so I'm going to write this as 2 before I cube it. So 2 3/8 plus 1/2 times 2 cubed, 2 3/8 plus 1/2 times 2 cubed is 8, so that is simply 4. 2 cubed is 8 times 1/2 will give me 4. Now, I'll add the fraction parts. 3/8 plus 0 is 3/8, and the number parts, or the whole number parts, 2 plus 4 is 6. So I end up with 6 3/8 for this problem. So 6 3/8 is the answer to that. What I want to do next is move over to this board here and take a look at what are called complex fractions. So let's move over there. This expression right here is called a complex fraction. I have 3/4 divided by 2/3. Fractions that contain other fractions in their numerator or denominator are called complex fractions. Well, the fraction bar in this case we can think of as being division. So we can think of this as 3/4 divided by 2/3. So since division by 2/3 is the same as multiplication by its reciprocal 3/2, we change to that and then simply multiply it. The answer is 9/8. There's a second way to do problems like this that are complex fractions, and that is to go through and look at all the denominators involved in the problem, find the least common denominator for all of them, and then multiply the top of the complex fraction and the bottom of the complex fraction by that least common denominator. In this case, you'll see if I multiply by 24, I have 24 times 1/3, 24 times 1/4, times 1/2, and times 1/8 down here. Then 1/3 of 24 is 8. 1/4 of 24 is 6, 1/2 of 24 is 12, and 1/8 of 24 is 3, and that just gives me a simpler problem to work with that just ends up being 2/15. So let's go to the board now and look at our first complex fraction. I have 2/3 divided by 3/4, so I'm going to rewrite this as 2/3 times 4/3. So instead of dividing by 3/4, I multiply by its reciprocal 4/3. That gives me 8/9. And that is the easiest way to do a simple complex fraction like this. Just think in terms of division, rewrite your division as multiplication by the reciprocal. Here's our next one. 1/3 plus 3/4 divided by 2 minus 1/6. Let's try our second method here and go through and look at all the denominators. A denominator of 3, 4, 1, and 6. The least common denominator for all those denominators is the number 12. So I'm going to multiply the top of this by 12 and the bottom of this by 12. When I do, I have 12 times 1/3 plus 12 times 3/4 all divided by 12 times 2 minus 12 times 1/6. 1/3 of 12 is 4. 3/4 of 12, let's see, 4 divides into 12 3 times 3 is 9. 2 times 12 is 24, minus 1/6 of 12 is 2. So let's see, 4 plus 9 is going to be 13, and then 24 subtract 2 is going to be 22. And that's in lowest terms, so I end up with 13 over 22. So two complex fractions and two different methods of solving them. With this method, I think in terms of division and rewrite it as multiplication by the reciprocal. The answer comes out very quickly. This is a little more complicated problem, so I try the second method where I find a least common denominator for all the denominators in the problem, multiply the top and bottom of the complex fraction by that least common denominator. It simplifies down to this. We could, of course, simply work in the numerator separately and then work in the denominator separately until we got a single fraction here and a single fraction here. Then this problem would have this form, and I could use this method to it. But in any case, you want to become familiar with both those methods, and there's enough problems in the problem sets to allow you to practice both those methods.